Well, dear guests, and Ms. Zhang, and good afternoon. Indeed, I'm very happy to stand here to share with you on AI model development trend in autonomous driving. I think there are two features of AI in autonomous driving. There are two major vertical applications. And first, autonomous driving could have many scenarios. It doesn't matter which business you are in, you always need to move something, right? Move the cargoes, move the people. In the past, and that way, and have to use people to do the transportation. But in the future, autonomous driving can do that job. And we should understand autonomous driving depends on AI a lot. Well, let's say today, when you are driving, mainly it depends on your intuition, right? And however, in an AI, it's hard to describe what is an intuition. If we look at the technical architecture of autonomous driving, and we can see different key parts. For example, from the bottom to the top, for the green color part, which means these are the work done by human brains or intuition.
It's about how to sense the world and how to control the vehicle. So this is intuitive, and it is out of your conscientious, and we need to make it AI, and AI really can help us to achieve that. And so for the autonomous driving, and it already started in the 1970s. Now we have come a long way. Now let's have a review about the history of autonomous driving. For the autonomous driving, in the very early stage, it's about sensing sensing the surrounding world. Here we have sensors like the camera. So, and to do the segregation of these information. So, based on this RetNet, this neural network. So, this standard neural network is not ideal. Then we need to optimize it, like ResonNet for the facial recognition or ID, and it's good enough. But for the autonomous driving, we need to streamline it. We can add the structure. This is really very important. They have various kind of a layer, and to add these layers, so the network could be optimized. It is, for example, 20% better than the existing network. So the network is more enriched. Various neural network optimize the camera information, camera data. So the result is better. So later, the active sensor like radar. So these image-based sensing is not good enough. Then we have a cloud fusion, like a laser, and the vision will combine together, and also various branches. So in the top is about vision, and the bottom is laser, radar, and then integrated together. And also CF is cloud fusion. So these are combined. So the sensing or perception is stronger, better. So later, this way is not enough. Yeah, for the static is good, but for the moving object it's not so good. So we have the bird's eye view. So is to have the kind of forecast or prediction based on the moving trajectory. So it has more capability. Only will be able to see what is the current situation. Also will predict what this object will move in the future. So these are being realized by the deep learning. We have like the target, the measurement, and also the segmentation. So this is based on the detection and segmentation. That's not enough. And then there is some new applications. Now after the object be identified, what is the next step? The next step is the forecast or prediction. I believe that this is the earliest generative network. Then we have an answer. So actually we have a trajectory. It's not answer, it's a trajectory by the network calculation. It is a new trajectory. This is the early stage of a generative network. RNA or LSTM. These are the early model. So we have this theory. One person made a trajectory of the neural network. So various kind of the image information will have the convoluted calculation and to have the capture of the characteristics. If I want to predict the future 10 points, then they put a 10 LSTM model. Then finally there will be 10 points. This is an early stage and very good outcome. But now it's really outdated. This is 2019. And then another one. It has a synthetic network. It's about the future, about a forecast on the future. Make this network combined with a Monte Carlo searching. Maybe it's the Go, chess. So these the kind of the Go or chess or gamble, they have Monte Carlo for the prediction of next step. It will predict what the participants will go in the next step. So and provide some status information for the future planning. Some people, they conducted a study. They say we do the prediction about where the vehicle will go and to have this gas pedal planning. So this is an end-to-end prediction. This is only for the status information. We import the camera and import the vehicle trajectory and the gas pedal, etc. So it is a little bit complicated. Then do the calculation, then put the vehicle speed, then the outcome will come out. It is based on the MT model. This is application of a neural network in our industry, like object identification, also about the future trajectory generation. So this is not only about identification of the object, but also about the prediction of its trajectory. As LTM, it also has its model LSTM, and we have a transformer to replace it. Transformer has more good mechanism. For example, GPT, it's generated the pre-training transformer and CNN. The difference And a transformer is about the focus mechanism. These variables and to have a cross computing. Well, if there is a good similarity, it will be noticed. If no, not noticed. And the second is about location information. We know where the location is. So, and if there is a good location awareness, then the vision will be better. The forecast will be more accurate. They already put forward that, and especially GPT, make it more popular. So, transformer model is really widely used and used in early stage, especially from the 2020. There are many papers about that. Based on the transformer, they will have the map recognition. They will have the like a lane and also isolation information. Now it has become a server model. This is really the most advanced the topic. This is about map generation. Also another one, they have the unified identification, unified speeding, about the vision information and the leader information. All will be the 3D pixel. In this 3D space, it have a transformer to recognize one concrete object, make this recognition more accurate. In the past, we mentioned about various model. They have a different lane to identify different elements. Then this one make it universal. It's a UVPR. Then later on, we have a new model. How to identify the object relationship between different frames. We have the different data received and whether they have a correlation between different data. So this is a 3D concept. You can see there is a machine recognition. There is this is query. We replace the frame. This is also concept of transformer. U, K, and V to control this value. U, Q is a query. It's a query to realize that goal, to correlate a different frame object, to be very clear about this direction of the object movement. This will be more sensing accuracy. CNN replaced by transformer, and to recognize different objects and do the detection and classification. It's a very good outcome. This is 2020, and then 2023, 2024, we have a new trend. This autonomous driving model is standardized the generative model. So for the autonomous driving, there is another term called end-to-end autonomous driving. We import the sensor information. It will generate the vehicle trajectory. For this work, computer is the first person made it. Different kind of sensor, put it together to have the transformer calculation, have the vector, then go to MMT. This is a multi-level, and for the processing, after processing, then the predict 4 points, GLT. This is also network called the gate control network. There are 4 points, 1, 2, 3, 4. Then for this, then people believe that this is not good. It's not clear enough. Then the data generated, it's not accurate. Then the planning will be not accurate. So some people proposed the unit board for the driver. They have many kind of all the sensor data will be recognized, identified. Then identify its trajectory, have a transformer model, and make a map, make a transformer. In the query, one query is one type of object, maybe a vehicle, or maybe a map, or maybe another road user. So different query will correlate to each other. Have a motion former, then do the forecast. And what will be occupied, what will not be occupied. Then this the trajectory, and we refer to its GPS pathway. So you can see this is an end-to-end network system. In the autonomous driving, you can see. So from the identification to the prediction and the planning is getting smarter and getting better. So first of all, the product is more enriched. So it has different self-adaptive and a new chassis, so different vehicles for passenger and also for the goods, but it's done by one software. It can also have the intelligent upgrading on the vehicle. 2023, it has many small modules for unified planning. In the future, it will be a unified large model, and it will be the future trend. The large model will have automatic allocation. This is for the autonomous driving. This is the progress of AI. For this industry, AI is wholly reliant, and not only about technology innovation. The vehicle will get better. What company? We have the 7 or 8 years of experience. The core technology, we mentioned that AI algorithm, etc., and hardware system. These are developed by us. We have applied for 100 patents.
And today, and we have seen, and no matter those autonomous driving technology used in steel industry or many other industry, and they are using our technology. So next, I want to talk about this kind of an unmanned product. Autonomous driving can be easily and expanded into various industries. And China's industry and value production and is in 7.8 is in 78 and trillion in RMB. So when we look at this an industry, or all the industries, and when something is produced, and then they need to be shipped into somewhere. Now let me give you one example. Let's look at the steel and iron industry in China, and the logistics and the cost and is around 20 billion RMB. So it's very expensive. If these unmanned and the vehicles and could substitute and human and workers or drivers, and I think and it can help you to save a lot of money. So based on an hour and calculation, maybe in 1 and 2 and 3 years, and you can see the return get and payback. So, and we think artificial intelligence and that can really help and our autonomous driving and go to another level. So let me show you more corporations and our customers. And on this slide, and you can see that some of our customers in their factory, and they are already using this unmanned technology, autonomous driving, and this is a customer name list. All right, thank you very much. That's what I have.